All right, is this thing on? Good. Before we get started, let me just make a few announcements. First off, please don't forget to submit your feedback on the way out so we can come back again next year. Second of all, lunch will be served, I think at 12:20 now is the time, since things have gotten pushed back a little bit, but there's like no rush. You have like a couple hours and you can just come whenever you feel like it. So you don't have to rush over right at 12:20. And third, if you haven't gotten a badge yet, please make sure you do so by 2 o'clock. We're here today to tell you about the Google Juice project. My name's Bob Lee. I created it and released it for open source just over a year ago. And this is Jesse Wilson, who's my new co-lead on the project. And I'll tell you a little bit more about him in a few minutes here. So first of all, the big question is, what the heck is Juice and what can it do for me? Well, I'll start off by telling you about the problems that we're solving. One of them is, I think like the main problem in my mind, is getting rid of boilerplate code. Right now as Java programmers, we're all familiar probably with the gang of four and the factory pattern and that sort of thing. We write these same patterns, this same code, this kind of same boilerplate factory code over and over and over again. We almost don't even think about it anymore. But that is effort that we don't need to extend, and we don't need to have all that kind of fluff, boilerplate fluff. The second problem that we solved, and this was like a big problem we had back when we worked together on Google AdWords, which is a gigantic Java app, was we needed a way to modularize our Java code. And with just plain Java, that's kind of difficult, and there's a lot of undesirable trade-offs you have to make. Like you can break things down, but then you lose some compile time checking, or you have to like jump through some hoops with your build system and that sort of thing, and have all sorts of source roots. Well, Juice tries to make that a lot simpler and enable you to break your application down into simple compile time units that you can work on independently. A third thing, another place where you see a lot of boilerplate is with relation to what we call scopes. And by scope, let me just kind of illustrate with some examples. We kind of think of singleton as a scope. We think of like the HTTP session and the request as scopes. And if you've written web applications or even just singletons, you might have written this same code to like lazy load an object in that scope over and over again, right? Everybody's intimately familiar with the lazy loaded singleton pattern. Well, Juice aims to get rid of all that and make it so you can write your scope code once and then just reuse it in a declarative way. And finally, one of the things that Juice makes it really easy to do is easy unit testing. Java out of the box isn't very good at that because, I mean, it was created in, 94, long before at least I cared anything about unit testing. And I think it's pretty clear that plain Java wasn't really designed with that in mind. So before we get into too many technical details here, I'm just going to kind of talk a moment about the philosophy behind Juice. And it's not just one thing, it's many things that kind of make the framework what it is. And then I'm going to turn things over to Jesse Wilson, who's going to kind of give you a technical introduction to Juice. Kind of like I think the most basic philosophy of Juice is that we kind of took a back to basics approach. And this is kind of, I guess, in reaction to, I guess, kind of like the enterprisey Java side of things. Java 5 really came along and changed the game with generics and annotations and gave us a lot of tools that we could use and solve some problems that we previously had to work around in undesirable ways. And by that, I mean, like in Java EE, you see like just kind of proliferation of XML, and people just kind of throw type safety out the window. So we took those like new features and said, well, hey, with these new things in mind, how do we want to start over? How do we want to build things the right way? If you're probably confused as to what Juice is and what problems it's going to solve. But the simplest way for me to explain it is in Java right now, whenever you need to get a new object, you have to find a dependency. You can either call a constructor on some concrete class, or you can write a factory, or you can call a service locator or something like that. And I see those as two opposite ends of a pretty wide spectrum. You can either have like brief code but tight coupling on the constructor side, or you can have a lot of boilerplate code and loose coupling on the factory side, and you have to write that same code over and over again. Well, Juice aims to give you a third option somewhere in between. You get brief code, almost as brief as if you called a constructor, but you get the same flexibilities as you'd have with a factory, which basically means if you decide later on you want to come out and introduce a new implementation or change out your implementation, you can do so by changing your code in one place instead of 15 places like you would if you were calling a constructor. One of the other philosophies that goes into Juice that I think people really appreciate is this idea of failing early but not too early. I'm mostly an application developer, not a framework developer. So going into Juice, what it originally did was as soon as I encountered an error, like a missing dependency or something like that, I would just blow up with an exception. And that's the right thing to do in an application. But what we quickly, and that's what most other frameworks do. But what we quickly realized here was that's not actually what you want. What I really want is for Juice to go as far as it can go and find all the missing dependencies within one run, and then give me an error for each one, much like a compiler does. So that's one of the things you'll see that Juice does. So you don't have to keep fixing one error, running your app, fixing one error, running your app, fixing one error, running your app. And it even goes so far as like with our kind of like the foundation we've built for tool support, it means that like in Eclipse and that sort of thing, you'll eventually be able to see these errors along with all your compiler errors at build time, which is really, I think, the most desirable way to do this. Kind of like an overarching philosophy for this whole thing is I want to make it easy to do the right thing. Like I said before, with plain Java, it's the easiest thing to do is to use static and call constructors directly. And it's really easy to write untestable code. I mean, how many of us have been there? Like, definitely. If you just write with plain Java out of the box, you end up with a big kind of, you can easily end up with like a big rat's nest. Well, I want to make it, I have a theory that you need to not just make it, I have a theory that you need to make it easiest to make the code unit testable for people to actually make it unit testable. Otherwise, if they don't really care about testing as much as you do, they're not going to go to the links and they're not going to go to the extra effort. They're just going to do the easiest possible thing. So we want to make it sure that people write unit testable code by default. The third thing, or the fifth thing that is that, like I said, when Java 5 came out, it kind of changed the game with generics. Before that, before Java 5, I really don't think type safety mattered that much in Java because just even the most trivial code, if you had like a collection or something like that, kind of type safety went out the window. And all the frameworks written around that time, like Spring and Struts and all that sort of thing, they obviously threw type safety the rest of the way out the window because it didn't really matter. You didn't get much benefit. Whereas with Java 5 and with generics, you can really, truly, with a little bit of effort, write truly type-safe code and have like type safety end to end. So it's really worth holding on to now. And in that vein, I think I like to think of types as the kind of natural currency of Java, and that's as opposed to kind of arbitrary string identifiers, right? Like your IDE and your existing Java tools can understand types. They don't really understand strings except for like with maybe special tool support. So what you're going to see in Juice is when I ask for a certain dependency, I don't say, hey, I need a dependency named foo. I say, hey, I need a dependency of this type. I need like an executor or something like that. So that's how you communicate with Juice. One of the other ideas that we like is we prefer annotations to convention. And that basically means instead of using some kind of naming convention where like maybe you name a method provide foo, we prefer to explicitly annotate it. And that kind of goes down to one of the other philosophies below, where we like to focus on readability over writability. You're going to write this code once, but 50 people may come along and read it. And having that explicit annotation on there makes life a lot easier for them. That way they know that you explicitly meant to do this, and they know your intention right away. They don't have to guess about it or eyeball and identify this special convention, or they don't even have to know the convention. They can just see the annotation there and know that something's going on. One of the things that we all hear is that singletons are bad, but really, I think it's just the kind of classic implementation of singletons because they rely on a lot of static state, and they kind of make them these global things. Well, with Juice, we kind of take a different approach to singletons that makes them still unit testable, so you don't have those problems anymore. So it makes them a lot more viable. One of the things you'll notice if you looked at Juice, and those of you that have already looked at it probably have seen this, is that we really believe in maximizing the power-to-weight ratio of an API. And what I mean by this is there's public, and then there's published. And we focus really hardly on the published aspect of our API, basically the stuff that goes out to you and the stuff that we say that you can depend on. And if you look at Juice, it's minimal. There's nothing in that API that you're not going to have to care, that you're not going to want to care about at some point. And what that basically means is that in the future, the Juice design is going to be really long-lived, and we're going to be able to keep extending it like we've been doing in Juice 2.0 without breaking backward compatibility. And that's really important to me, considering that we use Juice within Google, and we have literally dozens of big projects that use it, and I can't afford to go around and update them all every time we want to break an API. And finally, we believe in balance. Just because you can do something doesn't necessarily mean you should. We don't just throw in every little feature that kind of comes to our mind. We heavily focus, we heavily vet new ideas and that sort of thing, and we ask ourselves, is there another way to solve this? And we try to pick more general features that'll solve like a whole host of problems versus one feature that solves one specific problem. So I just want to touch on type safety just for a moment here, because I think that's one of the things that really sets Juice apart from other approaches. So to me, a lot of times when like dynamic language people try and shoot down Java, they're like, I don't really care about compiler errors. It's like my unit tests will catch that. Aside from the fact that their unit tests don't seem to catch a lot of the other stuff from my experience. But to me, Java is not, compiler errors are kind of like the least benefit that I get out of having a type-safe language. I mean, like with a modern-day IDE, all of us that use IDEs know that I can't even remember the last time I really saw a compiler error, because my IDE helps me write type-safe code in the first place. The important parts of type safety to me are like the additional tools you get, like defined usages. It's like I'm in like a multi-million line code base, and I can just effortlessly navigate it and jump from line to line to line. Like when I get into like some Ruby or code or something, I have a much harder time following because like the code's global state and anybody can change it out. And then I think part of the other thing is that people that aren't really familiar with the tools like all of us are, or hopefully most of us are, they kind of look at these refactoring tools and they seem so simplistic to them. You have like renames and method end lines. They're like, whoa, what if I want to do more advanced things? But I think the thing that I realized is that you don't need specific, like Juice, you don't need specific tools to do all those things. Like these little atomic refactoring tools can kind of combine up, and you can perform these really complex refactorings, right, with just like kind of a refactoring molecule. So I just came up with this graph the other day to kind of illustrate this idea I have and the kind of idea that drives Juice. We call this the productivity continuum. And as you can see, like on the x-axis, you have increasing flexibility. And on the far left side, you have Java, where it's static and it's pretty inflexible. Like you have to implement interfaces. Everything's checked at compile time. And on the far right side, we have a very, very flexible language. I picked on Ruby here, but you can insert whatever dynamic language you want here pretty much. And basically, it's more flexible because with Ruby, you can replace any code is global state. You can replace any piece of code, right? So it makes it very easy to test, very flexible. But also, as you can see on the y-axis here, we have what we consider the maintainability. And as you can see, I kind of rate Ruby down a little bit on the maintainability scale, because I think that flexibility kind of comes back to bite you. It's a little too much flexibility, right? If I can just change out a class and replace it globally, if I'm somebody, if some other developer can do that, it's not very easy for me maintaining the code to know that that happened. And it's not very easy for me to figure out what happened. It's like I have to rely on grep and that sort of thing, because you don't have the type safety to fall back on. Well, I see, so if Java's like a little bit down, kind of like the left side of this loop, I see Java plus Juice as providing more flexibility. Like I said, it gives you a little bit of dynamicity, but in like a type-safe way. And enables you to swap in your dependencies and stuff and reuse your objects in different contexts. But you still have the maintainability. We did not sacrifice type safety pretty much at all. So you can still, we have some tools already, and you can build, we'll certainly have more tools in the future that'll help you navigate your code and tell you things like exactly what implementation of a dependency you're getting. So you notice I didn't put it all the way up at the top, at the top of the curve, because there's some kind of magical language up there that doesn't require a workaround, like what I consider a workaround like Juice. And it's basically, my ideal language, I think, would be something like Java, only created with things like unit testing and dependency injection and that sort of thing in mind. Yes? Do we have a Juice plugin? Is that what you asked? Yes, actually we have one in beta right now. It's a Juice plugin on Google Code. We had an intern that did it last year for Eclipse. And while we're on that, we have these certificates for ebooks, for free ebooks. Like there's a couple books that have been written on Juice. So if anybody asks questions, we'll give you one of those. We have up to 25 of them. And we encourage you to ask questions throughout the talk. All right. I'm sure you're getting tired of hearing from me and you want to get down to the kind of the juicy details. Like I said before, Juice 1.0 came out just over a year ago, and we actually haven't had to have an update release because it hasn't had any significant bugs. I mean, everybody's really happy with it, and right now we're crunching on Juice 2.0, and it should be out sometime this summer. And that's why I want to introduce you to Jesse Wilson. Those of you who have used glazed lists might already be familiar with him. That's another open source project of his. Juice user, and now he's a huge Juice contributor, and he's been actually doing most of the development on Juice 2.0. So let me turn things over to him. Jesse.
So I'm going to basically just walk through a very simplistic application and show some of the problems with the standard Java approach when you try to do, when you've got these services that have complex implementations and you've got dependencies that you want to sort of sort out, and you want to make your code so that your dependencies are narrow, and you want to design your code to depend on interfaces rather than implementations. And so I'm going to basically just walk through the way I would write this code 2 years ago when I started at Google and we didn't have Juice, up to the way that I would write this code now that we do have Juice. And I'm going to try and point out the productivity benefits that we're getting, and sort of the ways that we're all, the way that our application is surviving because of Juice. Because when we started into this project of making everything in AdWords Juice friendly, we really had an unmaintainable application on our hands, and now we've got something that is sort of a testament to taking a crappy spaghetti code base and making something that's very well factored and maintainable. So the particular example I'm using here has 3 actors. It's got a biller, so I work on the billing system at Google, and a shopping cart, and a unit test. So we're going to just sort of show how these 3 things interact and where the dependencies lie between them. So the first approach I'm going to go into is the factory approach, which is sort of the canonical, regular approach that Java developers are sort of handed down. And when you sort of write hello world in Java for the first time, this example follows shortly thereafter, where I've got some interface and I want to get an implementation of it and do something with it. And then I'm going to show how dependency injection sort of solves some of the problems that come about with that standard example. So here's some common code that's just going to, this is to set the stage for the example. We have a slightly more sophisticated billing interface at Google, but the idea is that you can bill a customer some amount of money, and then we've got implementations of that biller. And these implementations are very, very heavy and complex in terms of all of the things that they need to do internally. So, for example, the Google Checkout biller may need to do some I/O work. It may need a server to be up and running on a different system. There's all sorts of configuration that needs to happen so that you can have a secure connection to your biller. So just using a Google Checkout biller means that my application size grows by, say, several hundred classes, because I need all of its dependencies. So what we sort of want to avoid is using the Google Checkout biller when we don't really care about how the biller is implemented. And so in that case, what we want is something like a mock biller that is a trivial implementation of biller that does the same thing as far as a test is concerned, but is much less work to set up. And so what I'm going to show in this example is we want to wire up our production application to use the production Google Checkout biller with all of its dependencies, but we don't want to have it slow us down in our development cycle and in our testing cycle, because it's got a heavyweight system behind it. So into the factory approach. This is sort of, I assume that most of us have written code like this before. The most interesting line is probably the get instance method, which is where you expose the standard billing implementation to the world. And so the problem with this code is that it's static. And so the dependency on a biller factory depends on Google Checkout Biller. And what that means is that in order to compile the biller factory code, I need the Google Checkout Biller code. And transitively, anything that depends on the biller factory needs the checkout biller. So this is sort of an emergency, and this was an emergency internally at Google. We also have a method to set the instance of the biller, and this is what we're going to use in our test so that we can substitute out the heavyweight biller with the mock implementation. And so our shopping cart class that we're actually going to be testing gets a biller via the factory and then uses it to bill. And our dependency graph looks kind of like this. So the shopping cart depends on the biller factory, and the biller factory depends on the Google Checkout Biller at compile time and at application runtime, which means that anytime I need to use a shopping cart, I need to start up that heavyweight connection. And then that Google Checkout Biller implements the biller interface. And our test does some work to make it so that we don't need to use the actual Google Checkout Biller and we actually bill our customers while we're running our tests. So here we can say the code in blue is the actual interesting test code, and the code in black is the scaffolding necessary to set up the test. And traditionally, our code looks kind of like this. We went a little bit further with the try finally block, which means that if the test does fail with an exception, we don't leave the mock biller in place. It's very hard to write this code correctly because if your tests do fail, then what will end up happening is you'll leave your biller factory in an inconsistent state, which can mean that other tests in your test suite might fail for unpredictable reasons. So some observations, I guess a summary, there's a lot of boilerplate, especially in the factory class. We have this compile time dependency, and reusing the client code is difficult. All of a sudden, we have a huge amount of dependencies. So dependency injection it's a standard programming pattern that solves this problem very nicely. And regardless as to whether or not you're using Juice or any other dependency injection tool, you should definitely use the dependency injection pattern in your code, because this gets you 70 or 80% of the way there to solving these types of problems of dependencies. And this is sort of like the key to writing object-oriented code in Java is to use dependency injection. So in this case, we slightly change our code so that now instead of calling biller factory.getInstance, the biller is given to the shopping cart in its constructor. We call this injection, but really it's just a constructor parameter. There's nothing particularly magic or reflective about what's going on here. And so now what we can do is we can create shopping carts with arbitrary billers behind the scenes. So now this shopping cart code has no static dependencies on the outside world, and it's now sort of fully testable. It doesn't depend on the biller factory. It doesn't depend on the Google Checkout Biller or any of that. And so our test class becomes much simpler. We now don't need to do the try finally block of awkwardness. We don't need to set up the old, we don't need to replace the old factory or any of that. So you'll see that all the black scaffolding code disappears, and we can write unit tests just completely purely with a dependency injection pattern. And so this is just a summary slide to see we ripped out the 3 lines of code, but also the try finally block. That's particularly easy to get wrong. And so the problem with the traditional dependency injection pattern is that our dependencies don't actually disappear. They just sort of go up a level. And so we've moved the problem of binding the biller interface to its Google Checkout Biller implementation to whoever creates a shopping cart. So now it's no longer the shopping cart's problem, it's the people who create that shopping cart. And so we've given the burden to the client. And so it's kind of this turtles all the way down problem where as soon as we get the shopping cart's callers to use a dependency injection for shopping cart, then we have to worry about their dependencies. And this gets particularly gnarly because you end up passing dependencies all the way down and all the way up, and you need to know what your dependencies are. So this is gnarly eventually, but it's good at the shopping cart level, but it's still gross at the application level. As you can see in our application, the black arrows designate dependencies, And so you can see that the shopping cart no longer depends on the Google Checkout biller. It only depends on that interface. But the shopping cart factory, which is what all shopping carts clients depend on, still depends on the Google Checkout biller transitively. If there's any questions, we still got the free ebooks, so please raise your hand. All right. All right, I'm going to move on. So benefits of dependency injection, if I haven't hammered this enough, it's simpler and more reliable to unit test, especially here at the shopping cart level, not at its client's levels. And the dependencies are expressed in the API. This is ridiculously cool. So just as a consequence of moving the biller from the shopping cart's method to actually be something that you need to create a shopping cart with, now everybody who uses a shopping cart knows, hey, I need a biller in order to use a shopping cart, and the shopping cart is going to use a biller internally. So now when you're writing your application, you can say, oh, well, I need to use this class. And instead of sort of reading the class line by line to see which dependencies it's going to use, you can simply look at the class's constructor and say, oh, this class needs a biller, or this class needs a login service, or any of the other potentially thousands of services that your application might have. So your object creation is separate from usage. So now we don't have this problem where getting the Google Checkout factory and getting the Google Checkout biller and getting the biller interface are now completely independent. And we get the opportunity to do a little bit more reuse. So we can reuse our shopping cart for a different backend. So theoretically, we could potentially use this with a new double-click system, because now we have the double-click biller as an option. All right, and so roughly the same amount of lines of code. So I'm going to go into we've solved the first round of problems with the factory, and now I'm going to go in and solve the next round of problems with Juice. And I'll just sort of show how it does a little bit of the plumbing for you and makes your life a little bit easier. So I prefer to just use plain old code whenever I can. And so I'm always a little bit resistant to add a new dependency to my application, especially third-party dependencies. You know, why would we want to add another framework to depend on from our code? And so the framework sort of has to pull its own weight in order to be worth adding to your application and to sort of make your application depend on it. So there's the boilerplate issue, which is important, but there's a lot of other issues that come up when you do dependency injection or the factory pattern by hand. And these things are like bugs and static state and tests that fail inconsistently and unpredictable code. And so Juice goes out of its way to make it so that you don't have any of these problems. It does a lot of upfront type checking to make your application just a little bit more productive to work on, and it makes it easy to do the right thing. So if you find yourself writing programs that are difficult to unit test or even slow to start up, Juice might make these problems go away. So this is what Juice looks like. This is sort of like the Juice API in its purest form. And what we're doing here is we're saying, whenever somebody wants a biller, give me the Google Checkout biller. And so that's binding the biller type to the Google Checkout biller type. And this is, as Bob was saying, the types as the currency of Java. And this is in a module class. And so one of the core abstractions of Juice is that you take all of your classes and you write classes as interfaces and implementations like you were told to in school, but you didn't really realize what the benefit of it was. And in Juice, we finally give you that tool that lets you say, only in one place do I glue my interfaces to their implementations, and that's in your module. And so the shopping cart code changes almost completely, slightly, hardly even noticeable. We add an annotation to the shopping cart constructor. And this is perhaps one of the most controversial features of Juice, which is that we require you to have this annotation, even though the platform and the tool doesn't strictly need it. And the goal is for readability. So if anybody's reading your code and they see this shopping cart constructor, this is a clue to the code reader that this class is involved in dependency injection. Yes, so if you want to inject several parameters, you can just list them, just like a regular parameter list. Yeah, so anywhere that we've got the biller injected, you can inject multiple types. A question in the back? So there's a question about whether @inject is required on all constructors, and it's not required on sort of default constructors or constructors that don't have any arguments. It's a sort of convenient shortcut because those constructors are rarely removed. Okay, so this is the second part of Juice. The question was, can you inject concrete or abstract classes or interfaces? And you can inject anything, any type. So any constructor that you could see, you could slap an @inject annotation on, and get Juice to work with it for you. So there's other mechanisms that will let you inject fields and methods, but we're going to skip that in this intro. So here's the second part of Juice, which is, how do I take my Google Checkout Builder and make sure that I'm not building tons of these throughout the lifetime of my application? And the solution is very, very cute and simple. We just annotate it with @singleton. And so what Juice is going to do when it builds your Google Checkout Builder is it's going to detect this annotation and apply a scope to the biller. And a scope is this really clever abstraction that Bob came up with, where you sort of take the idea of a lexical scope in your computer program and you apply it to the scope of a object in your actually running application. So you've got singletons that live throughout the application, and you've got session scoped objects like the users who's logged in and their settings. And you might even have request scoped objects for the duration of an HTTP request, so you can avoid making expensive calls that aren't going to change during a request. So this is how the Juice structured code has changed. So now our module depends on the biller, but the rest of the code is completely independent. And so how do we get the shopping cart back in the, so we still have this problem of, like, how do we get the shopping cart? And I'm going to go into that in a second. But I'm going to first take a short tour and show you the test class, which hasn't changed at all. So all we did was we added the inject annotation to the shopping cart class, but we can still test it just per the normal dependency injection strategy. So our test is exactly the same as it is with standard dependency injection, and this is kind of one of the selling points of Juice, which is that you don't need Juice to use Juice. So if you're using Juice in your shopping cart or using Juice throughout your application, you can write plain old Java code to do all your tests. You don't need the framework, and anytime you want, you can abandon the framework, and everything will work exactly as it was designed. So the conclusion of this comparison, we've got less framework code. I guess we counted 20% when you remove all the factories. There's more startup checks, so now we can make sure that the Google Checkout biller is going to be available when we start the application up.
And this is one of the key differentiators between Juice and using a service locator like JNDI or something like you might have in the past. With JNDI, if you're missing a dependency, you don't know until you actually run that code. But Juice, at startup time or build time or whatever you want, will crawl all of your code and look at all your classes and make sure all the dependencies are satisfied and fail fast.
Yeah. All right, so now I'm going to sort of transition into a part where I'm going to just show what Juice code actually looks like in practice and to handle some of the questions and how Juice handles these edge cases. There's a question in the back. Yeah, so the question was, how do you do is it possible to do injection in a unit test? And the answer is, of course, you can. Most of the time, you want to just sort of specify everything with mocks, but it's possible to write a unit test exactly the same way as you write your module with Juice. In fact, there's an open source project on Google Code, which is what we're using internally to test AdWords, called Juiceberry. And what it does is it starts up the full AdWords server internally at Google, and we use that in order to do functional testing with Juice.
Just a quick announcement. If anybody wants to ask a question, could you please come up to the mic so it comes through on the video?
So this is sort of the bootstrapping, how do we get Juice started? And so the application here is that we're going to use our shopping cart to build a pet store. So we're going to take that building module that we just wrote, and a pet store module that we're not going to show. And we can use injector.getInstance to create a pet store. And so what we can assume here behind the scenes is that somewhere pet store has got an @inject constructor, and one of its dependencies injects a shopping cart. That might be the pet store itself, or it might be one of its transitive dependencies deep inside the application. But the cool part is that from the main method of your application, you create an injector with your modules, and then you just get any particular type that you want to be your sort of top-level application, and you run methods on that type. And so what Juice is going to do is it's going to look at your pet store, look at its constructor, and then recursively build all of its dependencies. So all of those factories sort of collapse inside of this injector.getInstance call. All right, so I'm just going to go into some best practices of Juice and talk about why Juice lets you do these cool things. So Juice, we prefer constructor injection. And so there was a question where, would Juice support injecting other than the constructor? So can Juice inject a field of an already built class? And it can, but we prefer to do all the injections through the constructor because it lends yourself to writing immutable classes. It also means that your constructor is guaranteed to be called, and let's see, there's exceptions to the rule, so we'll get into that. Actually, we don't, do we?
No.
So the exception to the rule is if you have a superclass that has several subclasses. For example, if you have like a webwork action class that has several subclasses, you can use method injection to make it so that you don't need to rewrite the super constructor call in all of your inheriting classes. It's convenient crutch. Binding annotations. So what if we want two different billers in our application simultaneously, or if we want two different service implementations? So Juice allows you to create multiple bindings of the same type, and it differentiates them with annotations. So in this case, we create an annotation called @blue. Creating an annotation in Java is about 4 lines of code that you typically just cut and paste. And once we have that blue annotation, we can use that as a fully qualified name to identify a particular implementation. So how do we get more than one instance of an object? So if I wanted to create money objects or some other object that changed with each time, we have this interface called provider that has exactly one method called get. And so if you want to defer construction of an object, or you want to make it so that you can construct an object multiple times, rather than injecting the money itself, you can inject a money provider. I call mine dad. So you inject the money provider, and then you can call get on it successfully. This is a great way to do deferred loading. Binding.
Can you come up to do you mind going to the microphone real quick? Thanks.
All right, so you can bind constants.
On the previous slide, so are you injecting the particular implementation of money?
Yeah.
Okay.
So you can bind constants. So if you've got a properties file with a whole bunch of settings in your application, you can use bind constant to strip all the properties out of that and bind them all independently with their own annotations. So this is used commonly to do all sorts of property setup. We use it internally at Google to do things like setting up usernames and addresses for databases. All right, so can you wire objects by hand? So if I have an object whose widget constructor isn't annotated with @inject, I can still create an instance of it using Juice, using this provider methods mechanism that's new in version 2.
If you're working with third-party classes that you can't put the annotation for inject in, is there a way around that?
Yeah, so this is pretty much the perfect slide to ask that question. So what we do here is that you create this method called a provider method, and it's basically just a method that's got the @provides annotation on it. And what Juice can do is if you tell it about your provider method, it can say, oh, this provider method returns a widget. So whenever I need a widget, I'll call this method. And in order to call this method, Juice will also inject the arguments to the method. So in this case, the sort of process would be Juice would realize that it needs a widget, and it would say, okay, to get a widget, I need a blue service. So it would find a blue service recursively, then it would call this method and return the object as the widget.
Do you find this a little more almost intrusive than, say, Spring's dependency injection, where, you know what I mean? You don't have to even add it. The classes themselves don't even have to know that they're going to be used for dependency injection. Like you.
Yeah, the deal with Spring, and one of the things we didn't like about that is you have to maintain your classes, but you also have to maintain this separate XML in parallel, and you have to
keep them in sync.
Yeah, keep them in sync, and that's especially a pain when you want to do inject constructors like we like to. You have to either have to use argument indices, or like with Spring, you either have to do it explicitly and you have to use argument indices. If you reorder your constructor parameters, things will break. Or you can use their auto wiring by type, which is on the opposite end of the spectrum with juice being in the middle, in that it's really magical and you don't know that something's happening, and things can break.
We're really going for readability here.
Nobody really uses it. Yeah. Yeah, so we really wanted, it's kind of this same idea where you have like complete explicit configuration on one end of the spectrum, and then you have like auto wiring on the other end. Well, we wanted something in between that's still brief, but it's type safe and like tools can understand it. And you don't have to, I really didn't like this idea of having to keep things in sync in two separate files and stuff like that.
Yeah, it's kind of like the whole EJB, use annotations so that you can tell your configuration right beside your code. Yep. Question?
Yeah, how do you keep your properties outside also, like, inject your properties so different environments, you have different properties or so?
So scripts with this annotation called @named. And so it's like a standard annotation, but the trick with it is it takes a string argument. So you can use the @named annotation for each named property in a properties file. We prefer to use just regular unargumented annotations because it's easy to get a typo in a string, but that will get you most of the way. Yeah.
That's actually worth saying something more about, too. That's one of the things we found by moving a lot of this configuration into the code. You don't need so much complex external configuration. So in our case, we don't really use XML anymore. I mean, properties files serve us just well enough.
Yeah.
And one of the things that Juice can do is, like Jesse said, we have utility methods that are just built on top of Juice. It doesn't even necessarily have to be part of Juice. That goes through and automatically creates bindings for every key value pair in your properties file. And then you can have those injected anywhere in your app where you need those values. But the really cool thing that Juice does is it can also automatically convert the type. In 1.0, it could automatically convert it to a fixed set of types, like primitives, enums, classes, that sort of thing. But in 2.0, this is completely configurable. And I guess kind of the cool part is that all of these, Juice, like I said, Juice crawls your object graph and checks everything at startup or build time or whatever. So it only has to do the conversion once at startup, and if one of the values can't be converted, you find out right away, not when you're running your app. And you don't pay for the conversion over and over again.
So if you try to do a color conversion and you put the hex colors into your properties file to skin your application, then if you've mistyped the hex configuration or you've put a G where you meant all Fs, then Juice will blow up right at application startup time. Question?
Yeah, so if you have lots of constructors that you want to use the app inject annotation, right? So how would the Juice be able to pick which constructor you should use?
You're only allowed to have a single constructor with @inject on it.
You're only allowed to have one?
Yeah, Juice will explode if you give it multiple constructors that are all annotated with @inject. So it turns out that in practice, you usually only want one constructor to be your injection constructor. And usually that's the one that takes the full set of arguments. In all of our code in AdWords, we don't actually have any classes that have multiple constructors anymore, because what we used to do is whenever it came time to add a new parameter to a class, we'd create a new constructor, make the old one cascade into the new one, and then sort of deprecate it and lazily go back and fix callers. But with Juice, hardly any of our code actually calls constructors. It's almost all called by unit tests and by Juice itself. So we're much more free to do refactorings by adding dependencies to constructors. So scopes. This is very, very cool, and I'm fearing that we don't have much time to get into it. But the premise is that whenever Juice creates an object for you, it can keep that object around for the duration of some scope. Typically, these are singleton, request, and session scopes in your application. So if you want to take sort of a click log of a user's history throughout your web application, it's very simple to do with Juice. You create the log class that defines how the log works, and then you just simply inject that in singleton scope, or sorry, in session scope. And now what this does is every time a user starts a new session in your application, one of these classes will be created when you demand it by injecting it, and then you can mutate it, and it will survive throughout the duration of the session. It's very, very powerful, and you don't get into any of the nonsense with HTTP sessions where you need to use string keys and lazily populate things and do these checks where you sort of say, you know, if the session map contains this key, then do this. Otherwise, pull it out and do some casts.
And it's type safe.
Yeah, it's type safe and it's testable. So you don't need the HTTP session map to test your classes that are only sort of peripherally related to HTTP. So Juice has stages. This ties in nicely with scopes. And what this allows you to do is say, when I'm building my application on my developer workstation, I really don't want it to go in and spend the 30 seconds to initialize the Google Checkout Builder each time. What I'd rather do is make it so that all the singletons are built lazily, and so I can test just the core minimum of my application. But when you're running your application in production, you want everything to blow up immediately if it's going to blow up at all. So what stages let you do is toggle between fail fast, which is a slower startup time trade-off, or fail late, which lends itself to rapid iterations. And so with by hand development, when you don't have a framework like Juice, this is almost an impossible feature to get because you'd have to toggle that globally. All right, and so this is just a screenshot of our glamorous error handling, and it's modeled after the Java C compiler. And so the idea is that when your Juice module does something it shouldn't do, for example, if you're missing an annotation like @inject, or if there's some binding that Juice doesn't know how to fulfill that you've requested, Juice will give you a full error report when your application starts up. So you really don't lose anything by going to Juice. You effectively get all of the support you'd get by doing by hand dependency injection, but without any of its boilerplate code. Cool, and that's the last slide, so we made it. Questions, please. Cool.
I have a question about if you have a bundle of things that you want to inject into your class, where you would originally just maybe make a reference bean, and then you would reference that kind of that instantiation of the class. Now you're saying you add a lot of annotations, maybe several annotations before your constructor. Is there a way to bundle those things in Juice?
So typically what you'll end up doing is anytime that you've got a type that's distinct, you won't end up needing annotations for it. So in the biller case, it's fairly rare that you need annotations. The annotations really come in handy when you've got types like strings, where you really want the database username to be annotated. So in practice, that problem doesn't really come up where we need too many annotations on a constructor.
And also, in contrast to where some other places where you might have like a single string unique identifier, in this case, you can reuse the annotations across several different types. So you tend to have like more generic annotations like transactional or secure or read-only, that sort of thing.
Yeah. Are there any plans to integrate with GWT?
I've started to test the waters of integrating Juice with GWT, and the two tools are sort of complementary, but there's a lot of issues because GWT is really optimized for a slightly different model. In order to make this work, we're going to have to do some code generation. And so if it does turn out to work, it will be very cool. I'm not sure how complex GWT apps will need to be for this to be worth its effort. But effectively, it's going to do a code generation step. So all those factories that you would have been writing by hand, Juice will kind of write those for you.
So if I either have an existing app, or let's say I just want to use a lot of the Juice things, like the different style dependency injection, the scoping, and a lot of other great things that aren't offered elsewhere, but I'm already using Spring, and I like the Hibernate templates and the AOP and some of the other things that that's going to give me. Is there a recommended way to integrate the two and get the best of both worlds?
Well, it's kind of one of the cool things about dependency injection is that it's so flexible, and you can easily reuse these objects and wire them up in different frameworks just because of the way they're written, right? Excuse me. Like, for example, you mentioned, actually, just a couple examples. You mentioned AOP. We actually implement the same AOP interface, which actually Rod Johnson and I designed together, which was the AOP Alliance. So you can take your Spring transactional interceptor and use it with Juice right now. There's also, so far as other third-party integration goes, Dianji Prasanna, actually the guy that wrote this new dependency injection book for Manning, has this third-party Juice framework called Warp, which integrates Juice with kind of the Java EE specs and Hibernate and that sort of thing. And actually, the Hibernate guys are big fans of the way we did it because it really sticks to kind of Hibernate's model.
I'm using a Java library, Shindig, actually, which uses Juice. So my question is, it actually has a module that binds certain interfaces, right? So I want to change the binding. I want to rebind. Is that possible?
Yeah, so if you've got an existing module in place and you want to just take that module and change one of the bindings, there's a new feature in 2.0 that lets you override bindings. But generally, the preferred way to do that is to make your modules smaller, so that you say, you know, if I want 30% of this module and 70%, or sort of 30% of this module and 70% I want to override, you'd be better off to just break it into two modules and then have two different implementations. So you might have your Google checkout module and then your DoubleClick module.
I just have one request. Keep it lightweight and simple the way it is.
Yeah.
Thank you.
One more question.
You mentioned that you can, with the scoping, that you can integrate with HTTP request scopes, but that you don't have to have I suppose if you're in a servlet engine or something like that, you don't have to have the HTTP session there. So I'm wondering, how do you manage to have how do you scope something like that?
How does it work?
Yeah, like how does it work?
It's really simple. We just have a servlet filter that you put in front of all your other filters and servlets, and then it grabs a request and stores it in a thread local. And then Juice is able to get it.
So that's something that's just part of the jar file or whatever, that it
Yep.
just manages to just put it in the right place.
There's actually about 2 lines of configuration you need to do with your servlet container.
It's just another Juice module. Just like the modules that you write, there's a servlet module that creates all that. Yeah. Cool. We have a few more ebooks left. This is about all the time we have for the talk. So if anybody, I guess the first people that come up and grab them can have them. Thank you, everybody, for coming. We really enjoyed it.